Okay, so from here we finish until the question 5. So any problem? The girls, can you understand what I'm talking about this? Number 4 and number 5?
Yes.
Yes, Okay, so if yes, then we can continue for the next one. Okay, I will show you the graph. The graph that you plot, then we do the explanation. Okay, the graph become like this. Okay, this one is a graph. Just now you plot, suppose the shape is like this. Okay, from this one graph, we need to explain. Okay, the first part is this one. Okay, I told you already, this one is less than the R. This one is part is less than the R. Less than the R, G is the directly proportional to the R. Okay, so from here, that means your radius, when there's an inside the earth, there's an increasing with the radius inside the earth. Okay, so until where? Until the maximum. This one means surface of the earth. That's a maximum part until here only. So that means this one reading we know lah. There's a 9.81. This one's a 9.81. So until here, there's a maximum. So until this part, when they want to drop after the R, they want to drop, this part is the object already far away, that means on the surface, out of the surface of our earth. So from here, we find it gravitational acceleration, there's an inversely proportional to the R squared. So this one means when you're far away, the gravitational acceleration, you are less and also less. Okay, so this one is the third part. So I just label the first part. Okay, this one is exactly surface, second part. This one is the third part. This one, that means your R must be plus H. Okay, so this one is what they want to explain in your notes lah. They got the diagram at the bottom. After that, they got conclusion. Okay, then we go through to the table. I call you go back and finish it about the solar system. Okay, this one. Okay, we see about the first the solar system. Okay, this one. Okay, this one's a conclusion. That day we explained already about the three situation. Okay, now we need to do is the following. Okay, this one. So everyone, you complete already or not? I want the answer only.
Yeah.
Straightforward, give me answer.
Yeah.
Okay, then I go to this part. The first one, everybody know there's a 9.81, is it?
Yes.
Okay, next. Answer?
274.
274. Got decimal point or not?
No.
No lah. Next. Hello, moon. Moon is how many?
1.6.
1.61.
1.61. Okay, next. Mass.
3.70.
3.70. Okay, next. Venus.
8.87.
Mercury.
3.70.
Okay, correct. Next, Jupiter.
24.76.
Okay, next. Saturn.
10.42.
Okay, the next one, Uranus.
8.83.
Okay, Neptune.
11.06.
Last one, Pluto is
0.71.
okay. So this one is the answer. That means we just assume all the thing is a surface. So we're using this formula only to do the calculation. So I think there's no problem because we never do any outside of the surface or inside with the Earth. We just count this all in the surface. Okay, so this one is no problem. Then we need to go the following. Okay, anybody here want to copy? I think it's okay, is it? No one, nobody answer me. I can change the slide. Okay, the following. This one. I need to go the second part already. Okay, after you do all the calculation, we need to see the question, discussion. Okay, now we go to answer the first one. Which one planet has the largest of the gravitational acceleration? Well, your answer is? Girls, I want one of the girls here answer which one should be the largest. Planet lah, I want planet lah. Sun is not, how about the planet lah? In my class don't have any girl.
Jupiter.
Jupiter, okay. Okay, which one planet has the largest gravitational acceleration? There's a close with Earth. Which one? Almost the same as the Earth. Which one? Oh, nobody answer. B or 9.81. You find which one is closer with 9.81.
Saturn.
Yes, Saturn. Okay, then we go to what factor to determine the value of a gravitational acceleration of the planet? Which one should be the factor? You want to determine the gravitational acceleration. You do the calculation, is it? Which one should be the factor?
Mass and
also radius.
radius.
Okay, so should be the mass and also the radius. Okay, radius of planet. Okay, so this one is a factor. Okay, so today we need to go is this one. So that means the last time all the formula you memorized already. So coming soon, I want to introduce some more for the formula. Okay, so we continue with the centripetal force in the motion of satellite and also the planet. Okay, this one we label centripetal force Fc. Okay, one of the force related with the satellite when they're moving. Okay, let's see the diagram. We got three positions of the satellite, okay, which are orbit around the Earth at the uniform speed. That means all got velocity should be the same. Okay, uniform speed. Okay, but observe the direction of the velocity, the satellite for every position should be different. So from here, we just can say speed should be uniform, but direction should be different. So direction is a different means I cannot say velocity also is a uniform. I just can say every speed is the same, but velocity different. Why I say velocity different? Because direction different. The value should be same because of the direction. So that's why I cannot say velocity become the same. Okay, I just say the speed is the same. Okay, now we continue. A body that moves circular of motion always experience the change of direction. Everyone, when they move, they will change the direction of the motion even though the speed is a constant. So therefore, velocity of the body changes. Okay, velocity changes. A force is required to change the direction. So when I say they got change direction, they need some force. Need some force to make the satellite to change the direction when they want to orbit the Earth. So from here, this one, the force that act to the body, move in the circular motion, we call it centripetal force. So there's a Fc. Okay, understand? Okay, I just want to introduce centripetal force. After that, this one force used for what? Used for the body to move it. Okay, how they move? They want to orbit the Earth. So when they move, they sure got velocity. So later we need to count what is the velocity. You also need to count what is the force. Okay, this one got one of the activity. You can refer your textbook. Okay, there's a page 89. Page 89. So this one, they want to understand the centripetal force using the centripetal force kit. Okay, suppose you can create by yourself with just using one of the plastic tube, rubber stopper. Okay, you just put one small thing like rubber stopper. You're using your eraser. Then after that, the slotted weight, you just take something is heavier, you put at the bottom. Okay, after that, they're using the string. Okay, the string must be over one of the tube. You can using straw or anyone anyway. So this one you just clip. Clip reason is you don't want let the this one the string come down because this one too heavy. So from here you make sure this one string do not fall down when you just hold it. Okay, so from here the motion of the radius, you set this one the string 50 cm. Okay, after that the total mass you put 100 gram. So that means every time you don't need to put 100 gram lah. Just every time you change the mass of the slotted weight. So later we need to see when the mass increase, what happened for the string. So from here, they say hold the plastic tube in your right hand. When you hold it, don't let the string to come down. After that, slotted weight you hold by left hand. Don't let the slotted weight to come down first. Okay, now you hold tight, then you rotate. That means you hold the thing just like you want to swing something. You rotate the rubber stopper at the constant speed. So the situation like this. You go to rotate. Okay, you go to rotate. So that means when you rotate, you find it, you make one circle. You make one circle means you make one orbit. That means the satellite is moving around with the Earth. So from here, make sure the crocodile clip, you stay at the distance is 1 cm. That means this part, you make sure it's 1 cm. This one stands for what? This one stands for radius. You don't changes the radius. When this one just drop, that means your radius becomes smaller. So from here, we clip because we want to constant this one radius. Okay, when you make it become shorter, then your radius become smaller. So you don't make it changes. Make sure it's 1 cm. Okay, from the lower end of the plastic tube so that the radius should be fixed. Okay, after you rotate, now release the slot weight. Before that, your left hand is holding the weight, is it? Now you release. So when you just release, you also hold tight. Continue to rotate the rubber stopper. So now they want you to compare. Just now before you release, now you are released. What's the difference for the string? Okay, sure, the first one you find it become heavy already, something to pull down. Then you observe the speed motion of the rubber stopper. So what do you think about that? When you just release your left hand, what happened for the speed? Anybody can answer? Faster or slow? You know what? Just guess lah. You go later, you go back and try. Just guess. When I put the weight come down, become heavy already. So what you think about the rotation? Become faster or slow?
Lower.
Okay, lower. Because heavier. Because just now you said the mass affected, is it? So that means this one will become lower. Okay. So from here, this one is a one hypothesis. We assume when I just release, so I find it become lower. The speed becomes slow down. Okay, number 5, they say repeat 1 and 3 with the total mass 200 gram. Just now you're using 100. Now I'm using 200. Okay, now compare the speed motion and the rubber stopper. Sure become lower and lower because your mass increasing already. Okay, so the big object you want to move become lower because just the relationship we're using the common sense. When there's something just heavier, that's very hard to put it. That means you're using more force to move become fast. If you never apply more force to find the object, they will be very hard to move fast. Okay, so this one what you need to do later. Okay, then we continue to see what happened. Now we're going to see the situation, this one. The third part. Okay, third part is this one. So the third level, that means you are finding every part. You find it, the rubber stopper, they will move every part. The direction should be different, but the speed becomes the same because you are swing with the constant force. Okay, T means the tension for the string when they move to the every different degrees. Okay, then you're using the linear speed. Okay, so from here we're going to see the result. Okay, the next page. Okay, this one. So from here, number 6. Repeat. Just now you changes about your mass, is it? Now say number 6 is to change another thing. Okay, number 6, you need to step 5. Repeat the step 5. When the rubber stopper is rotating, you pull the lower end of the string downwards. Means you're using the mass is the same now. Now to make the radius become smaller. I mean just now you make 1 cm clip, is it? Now you pull down more, 2 cm, then you clip. Means you make the rotation radius become smaller. So now they still want to ask, okay, feel the tension of the string action on your left hand changes. So what you think about that? The mass now I constant, I make the radius become smaller. What you think about the speed of rotation? Become fast or slow? Hello? Hello? Nobody answer. I make the string become shorter. Now I go to swing, become fast or slow?
Fast.
Yes, become fast. So from this one situation, we find it. When the mass at the bottom increasing, you need more tension to move it. If you don't want using more tension to move it, you find it becomes slow. Okay. So another situation is the mass I constant. Now I make the string become shorter. So that means the radius rotation becomes smaller. I find it, the rotation of the rubber stopper become fast. Okay, so the rubber stopper actually is what? There's a satellite. Okay, so the center, the force actually is what? There's a earth pulling force. Okay, that means the centripetal force. So from here, they just want to introduce 2 things. One is a velocity, and another one is a FC, the centripetal force. Okay, now we do the discussion or the just now activity. So when the rubber stopper, they are make a circular motion. The strength string exert the force on the rubber stopper. So what is the direction of this one force? Centripetal force, where they go? All the tension where they go just now. When I show just now direction, can you see the diagram just now? I go to rotate. Where the tension go? Can you see all the T go where? All the T go where? There you go. Can you see all the direction? Hello, where the T go? Or Jia inside or not? They answer or not? Where they go?
Go in.
Go in where? This one we call what? This one we call what?
Which one?
The center line, is it? All the tension must go in the center of the circle, yes or no?
Yes.
So this one is what the question they want to ask. They want to depend the activity. They never ask you about the Earth and satellite. So from here, we straightforward answer the question now, what they want to mention. So from here, 2 words. 2 words. The center of the circle. Okay, so this one is the answer. I'll delete it first. Okay, so this one. Then we continue. The relationship between the speed of the rubber stopper and the centripetal force. Out. The force and the speed. Okay? So what do you think about that? If the force more, you attract the force is more, what do you think about the speed? Hello? You apply more force to rotate it. What do you think about the speed? Okay, we do some example. Just now you increase the mass of the slaughter weight, is it? If your force constant, that means you never apply more force to overcome. You find it, they are slow. Okay, if I rotate, I want to rotate, follow the just now the 100 gram. Now I add 200 gram. I want to rotate same like just now. I must apply more force. Yes or no? Because you got 200 gram below your head. So now you are holding the 200 gram. Then you want to rotate. So your force to hold 200 gram increase already. Now you go to rotate. You tell me the force applied, the strength become higher. What do you think about the speed? Below. I'm using more force already. You got the terpaksa to hold 200 gram. The whole string. You think faster or slow?
Fast.
Fast. What situation is slow if I never increase my force? That means the mass 200 gram already. I still just hold it, then I swing. That will slow. But now I follow just now, I hold it, and I go to swing. You find it, they are faster. Unless I never afford. I never provide any force. Now the terpaksa must come out the force because I need to overcome the 200 gram. So from here you find it when the force become high, when you apply the force is more to swing the rubber stopper, you find it will move faster. So from here the conclusion just now, okay, they never say constant the force law. That means the slaughter weight just now is represent the force increasing. The force increasing, you go to hold it. So that means when the force, you hold the force, okay, this one is the string, just now is the slaughter weight. If I make 200 gram, so you hold here. When you just hold here, you need to using higher force to overcome 200 gram. After that, you go to swing. You go to swing the rubber stopper. So that means now you are more forced to swing it because you want to hold this one. Okay, so from here I find it fast. That means force and also the speed relationship is directly proportional. Directly proportional. Okay, directly proportional force and speed. Okay, the next one should ask about the radius. Force constant now. How does the centripetal force change with the rubber stopper make the circular motion with the smaller radius? Okay, this one, smaller radius. Okay, first one, your speed. Now they never say about the speed. They say centripetal force changes when the rubber stopper make the circular motion. Okay, radius becomes smaller. You tell me how about your force? I want to continue the speed. Now your radius becomes smaller. Now your force become big or small?
Small.
Okay, the force becomes small to swing it. Smaller radius. How does the center force? Okay, the force becomes smaller. Okay, because you want to make sure the speed, because if I'm using same force to rotate, it should become faster because your radius becomes smaller already. Okay, now how does the centripetal force changes when the rubber stopper make the circular motion? Okay, again, I'll let you see the diagram again. This one. Okay, now constant. This one is a tension means centripetal force. Tension. Okay, now I make it become shorter. I make it become shorter. Okay, what do you think about this tension? Shorter the tension should be become more or less. More or less. When I make it become shorter. Can you tell me anything? Because you never do this one experiment. So we just using our common sense. Okay, if the mass more heavier, you need to hold higher force. Okay, so higher force means your centripetal force greater. Okay, so mass this one higher, the centripetal force become greater. Then after that, if you say about the speed constant, because we do the relationship, the speed must be constant. Okay, next one, the situation is the mass here constant. Mass here constant. Okay, now the radius becomes smaller. Okay, they never talk about the speed. They just say what you think about the force you want to put it. The force attraction to the center. You think about stronger or less. When the rubber stopper make the circular motion when smaller radius. Longer, the tension become bigger, or shorter, the tension become bigger.
Shorter.
Shorter. So any other answer? Just I hang the picture. Okay? One like this. Okay, another one. Longest one like this. Okay. You tell me which one tension should be highest. Number 1 or number 2. Longest the tension become higher, or the shorter the tension become higher. Nobody can answer. Don't know. Never hang the picture before.
Longer, longer.
Longer again. Come back already. Some shorter, some longer already. Okay? I don't want to answer also. I want you to go back to try. You do this one experiment, then you tell me. You feel you are very hard to put it, mean that one is the tension. So you feel which one situation should be the tension become higher. The shorter or the longer. Like this only. That means tension means you're easy to swing and hard to swing. Like this only. Okay, I also don't want to answer. So from here, I just give you the answer 1 and 2. Number 3, you give me the answer. Okay, so this one is a centripetal force. Okay, now we go and see the definition. So your answer for me, bigger or smaller. Okay, now we're going to see the next one, the definition. Well, I go to open first. What do we see? Oh, wow, we'll find first. Where is that? Okay, now we go to the next one. Open the wrong thing. Okay, sorry, wait a while. I go to open first. Chapter 3. Okay, here. So we are until this part. Okay, now, so I empty this question. So you try first the activity, then you give me the answer for the coming lesson. Okay, now you need to introduce the centripetal force. There's a FC. Okay, a simple one, we just write there's a FC. Okay, there's a force that act on the body in a direction towards the center of the circle. Okay, towards the center of the circle for a body in a circular motion. So that means this one is a body. So after that, you are pulling the force to the center. This one we call FC, centripetal force. So from here must be related with the F1. Number 2 must be the mass. Mass means the body mass lah, the center of the body mass. And we got linear speed. Okay, where's the speed to go? The speed of the object you want to move here, or you want to move another situation. Okay, this one is a V, speed. Okay, after that we got radius of the center. Okay, this one is a center, then this one we go here, this one we call radius. So these 4 things must be related with the formula. Okay, now we need to join the formula. Linear speed, V show how fast the body moves in the circular motion. So that means the V stand for what? V stand for how fast they go to move. Okay, so from here, can you think about that? What's the factor to affect the centripetal force? What factor? Just now you see they want the circular. Which one can make the force become faster, become higher? How to make the force become bigger? The object is moved outside orbit, the Earth. How to make the force? You are the Earth. You want to pull the satellite. What situation can make you apply the force to the object is more stronger? Hello, can you see my formula here? I show you so many things here. F, M, V, and R. Now I want what will affect the F. The rest 3 things, is it affected the F?
Yes.
Yes.
Okay, we don't say about mass bigger or smaller first. We just say what factor will affected the force. So the first one sure is the mass of the body. The mass will affected the force. The second one sure is a velocity, or cannot say velocity, we just say speed. Okay, the speed will affected, and the last one sure is the radius. So that means the formula for the centripetal force must be related with the mass, speed, and also the radius. Okay, now we're going to see the formula. Your paper got formula or not? No, is it? No or not? Do you know? Okay,
Got.
got. So the centripetal force, the formula is a mv square over r. Okay, you remember what we learned about the force F equal ma? Remember, is it? So actually, there's the same. This one is another force. Okay, this one force just apply for the Earth. This one is a normal one. M is the same. M means the mass of the body. Okay, A. So can I write A actually is a V square over R? Okay or not? Another formula for acceleration. There's a V square over the R. V square means linear speed of the body orbit. The speed is how many? R means the radius. You are go to the center. Okay, so this one is a centripetal force formula. Okay, now we're going to see this part. Okay, so that means by comparing the formula of the force and also formula of the centripetal force, F equal Fa, and this one. So that means we can obtain A is how many? A is a V squared over R. Okay, any question? If no, we need to do example 1. Okay, understand the question first. Okay, through swinging the iron ball, horizontal circle before releasing. Okay, then the centripetal force act on the iron ball when the iron ball is moving. Okay, provided V. Then this one is a radius. This one is a mass of the ball. Okay, so the question what they want the F. So please apply straightforward. Give me the answer for the FC.
$1,600 N.
Okay, the answer is 1,600
Yes.
Newton. Okay, so this one the answer. Okay, this one just more number. They never using the earth mass, anything. They're using ball only. So I think this one okay, is it? Remember square only. Many of you forget about the square. Okay, if okay, then we need to continue the following. Okay, now we go to prediction of the Isaac Newton that the satellite can be orbit around the Earth without being driven by a rocket engine. Okay, let's see the first part. Here we got two situations. Okay, first one is A, for number 1. You see from here they got explanation. Your textbook also same. They say the object they launch with the low linear speed. You must move slowly. We follow the trajectory 1. Okay, first part. If you move slowly, you follow the first circle. Then after that, they will reach to the Earth at the cube. Okay, if you follow the sufficient linear speed, that means you are move faster already. Now you're following the second circle. Okay, the second circle is out a little bit. So from this one second circle, the object will not return to the Earth. They will straight forward continue the circle round the Earth. Okay, so this one, they just want to show the situation when you move faster, you are never crash to the Earth. You are continuous to rotate surrounding the Earth. Okay, this one is Isaac Newton. Let's say about the law lah. Okay, then we continue to see the next one. Okay, the next one should be this one. Okay, we can see the example 2. Okay, example 2, they're talking about the satellite lah. Now it's outside. They go to circle. Okay, go to circle. Now we see the info first before we want to find anything. Okay, first one is the weather satellite. They are orbit the Earth at the height. Okay, 480. Understood lah? 480 means you are already outside of the surface. Okay, what is the centripetal acceleration? They want to find acceleration. So that means they want to find A. A is how many? Okay, of the satellite. Linear speed of the satellite. Okay, first one they tell you what's V already. The radius they also give you. So now you need to find the A. Okay? Can do or not? Can do or not? Then is it? I think no problem, is it? So you just apply fees, So just finish, just on the mic, and you tell me what's the answer. So anybody finish? Okay, can get this answer? Because they asked about the acceleration, so we don't need talking about the force lah. Acceleration, then we know the formula is A equal V squared. A equal V squared over the R. So we apply V squared is how many? From here, they tell you the linear speed. So you take the linear speed, you go to square, and they tell you what is the radius. Okay, remember, we not just about the radius. We need to plus about the 480 kilometer because you are outside. Okay, the satellite is outside of the Earth. So from here, this one is your calculation. This one no square, the bottom no need square. Just a V, you go to square. So the final answer is 8.48. Hello, can get it or not?
Can.
Can ah? Nixon, you simply don't answer only, is it? Can you do or not?
Try lah.
Ayo. The others? The others will do or not? I see who is that. Who is on my line now? Nixon. Esther. Esther like no mic one, is it?
Yes, teacher.
Yes. Oh, yes. Okay. Eric, is it here? Eric.
Yes, teacher.
Can do or not? I find it one hilang already. Leonard P.
Play game.
Leonard P play game again. I want to complain already. Leonard. See? No response mean play game, is it?
Yes, teacher.
Yes, play game. You
No,
answer
no,
me
no.
is yes. Yes mean you play
No.
game. No, huh? Okay, so that means the answer, this one, or the example 2. Anybody want to ask? No, huh? No, I want to continue more harder one, huh? So I just introduce one formula only. That's a centripetal force. After that, from there, I create the acceleration, centripetal acceleration. Okay, then I want to continue the next one. Okay, the next one we see anything you can see or not here. Okay, this one. Okay, centripetal acceleration, that's a AC. It's an acceleration that direct toward the center of the Earth. So from here, they just want to create the formula only lah. So from here, I just show, okay, what's the formula for the force? So first one, formula force, F equal ma. Okay, centripetal force is a Fc. It's a mv squared over the r. Okay, then we make it equal lah. Fc equal the F, ma also equal mv squared over the r. So finally, which one we can cut? This one we can cut. So we can say acceleration is a v squared over the r. Yeah, so this one equation from the centripetal force create the centripetal acceleration. Okay, now we continue our lesson. We're going to see our paper again. This one. After finish this one, we're going to see the last part. Mass of the Earth. We need to find the mass of the Earth and also mass of the Sun. So that means this one citation is never giving the mass lah. You need to do the calculation. Okay, let's see the explanation. Okay, a body P, the mass is a small m. Okay, orbit the body Q, the mass is a capital M. Normally, the bigger mass one, we take it as a bigger mass lah. The smaller one, orbit one, there's a smaller mass. Okay, with the separation distance, there's a R. That means now you are on the surface between the respective center. Okay, now the uniform linear speed, there's a V. Okay, now they got speed, velocity here, they got speed, then right, there's a V. Okay, for the body P, centripetal force, now we make it as equal to the Newton universal law of gravitation. Remember this one or not? Still remember this part? We learn from static. Hello. You can turn your notes. You go to first page. Okay. The first page we learn about the Isaac Newton. The topic, Newton universal law of gravitation. That one we learn about the first formula. There's a F equal. And what is a law of gravitation? G, capital M, then small m, then over the R square. No. Hello, remember? 1 square. This one is the first page we're going to learn. This one is this one. Newton universal law of gravitation. Okay? If you're using just now the centripetal force, we cannot find about the mass of the sun and also mass of the earth. Okay? It must relate with this one, we can find the mass of the sun and also the earth because they got capital M. Okay, now we make two become equal. Two forces become the same. Now centripetal force, that means the Fc, same like the gravitational force, law of gravitational force. So from here, centripetal force is a mv squared over the r. Then this one is a g, capital M, small m, over the r squared. Okay. From this one question, we need to find is what? We need to find the mass of the sun and also the mass of the earth. So from here, we need to take out the capital M. You want to take out the capital M because you want to find the mass one. Okay, from here, which one we can cut? The small m we can cut because small m is stand for the orbit object. The object is orbit the earth or orbit the sun, the small thing. So the m actually is the same thing. So we go to cut. Now, after you cut, now we need to write the new equation. Okay, now your v squared. Can I move? Okay, I just write v squared over the r equal g, capital M, and r squared. Okay, now after I cut the m lah. Okay, now I continue. I want to take out the capital M. Left the capital M alone. So what I need to do? What I need to do? So this one R, move up lah, is it? Move, go up. V squared, R squared, over G, R. Okay? The R squared, I move up, G come down. So finally, which one we can cut? This one can cut, become 1. This one is no more. So finally, your M equal V squared over G R. One more R here. So this one is the formula. You want to find either the mass of the sun, either the mass of the earth. Depend this one, either sun, either earth. Okay? So this one radius is what? Radius for the object to the sun or to the earth. This one G is a constant number. Then the V is what? The linear speed of the object moving when they orbit the sun or they orbit the earth. Okay, so this one is a new formula when you want to find This one, the mass of the Earth and also the Sun. Okay, hello. Nobody answer me one. Means where everybody very, very clever already, is it? The learner is what? Right hand, play the game. Left hand, move the mouse, is it? Okay, until here, any question about this formula? Next one. It's a sleep already.
Yes, teacher.
We suddenly wake up.
Yes.
Oh, yes.
No,
Okay, now I want to show you the another thing. We go and see the formula. To show you this part. Okay, this one. Okay, let's see here. This one is, just now I show you, the mass and also of the Earth and also of the Sun. Okay, this one is one of the formula. Later we need to relate it. Okay, just now you find the mass. The formula is V squared R over the G. Over the G, yeah. Okay, so from here, we need to take out some physical quantity here. Okay, remember velocity. Okay, or you say the linear speed lah. So from here, they say from the formula for the speed, there's a distance over time. Agree? Before that, we learned speed is a distance over time. Okay, distance means what? Distance means the planet, or you say the outside, this one, the body, they are travel to make one complete orbit around the Earth. Yes or no? They move, they want around. So we count here the parameter of the orbit. That means there is a 2 pi r. So we assume the whole Earth is a circle lah. So we take this as a 2 pi r. So I take this one as a distance. Okay, distance of the planet, they go to orbit the sun. Okay, time taken. Time taken means the period revolution of the moon around the Earth. That means the body, you round one round. We count it as a period. Remember the period, time taken to make one complete oscillation. So this one is a capital T. So from here, I can write the V is a 2 pi R over T. Agree? Oh, agree or not? I just want to split velocity only. Because some situation, they want to count about the mass of the Earth, they give you the speed. Okay, if give you the speed, you are just apply this formula. If the question they give you the period of oscillation, they also give you the never give you velocity, just period only. So when they give you the period and radius, so that means you need to count by this formula. Okay, in your notes also got, they show you the notes here at the top. They can show you the V equal distance over the time. The distance means there's a parameter. Okay, the parameter of the circle. The circle of the Earth means they count as a 2 pi r. Okay, time taken. This one is a period of the body P to orbit whole circle of the Earth. That's a T. Okay, now I need to join this all thing together. Okay, by considering the Earth-Moon system, the mass of the Earth is formula. The mass of the Earth, V squared R over G. M stands for mass for Earth. V is the speed of the moon. R is a distance between the moon and also the earth. Okay, T is the orbit period of the moon. Okay, means the whole thing, just one formula is related with the earth. That's the best. The others, VRT, is related with the object orbit. Okay. So if I say I want to find the mass of the sun, your formula also same. Sun. Okay, now is the earth orbit the sun. So the formula same. This one is for the sun. V square is the earth speed. Radius is the distance between the earth to the sun. G is a constant number. T is what? The period of the earth to orbit the sun. Okay? So just this one is a big object. The rest is the thing to orbit the object. So from here, this one is a diagram. Okay, the force from the moon to the earth. This one, moon also pull, the earth also pull the force from the moon pull to the earth. This one is earth to the moon. So from here, just now information, I show you the velocity, how to find it. Okay, this one all is the information. Okay, one last thing, your notes don't have. I want you to write yourself in your paper. Okay, that is here. Okay, I open first. And here also don't have. Okay, never mind. I just write. Okay, I just write at this part. Okay, I write the simple first. V squared RG. Okay, then the V is equal 2 pi R over T. Okay, so now I want to make this one masuk dalam. Okay, before I show you the answer, you go in first. You bring the V go in, then you tell me M equal how many? You give me the M finally, what is the formula? Okay, do now. I just want the M. When you bring the 2 pi R go in, final, what is the formula? So Vinny, you just open your mind, just on the mind, you tell me, final, your formula is what? Anybody finish? Just bring it. Ishan, have you do it? Oh, Zhihui. This all thing they will answer. I mean, just on the cam, just on the PC, then they move away already. Is it? Nixon?
Don't know leh. Understand lah, sure.
Do you know what I'm talking about? What you need to do now?
Yeah, that one I know already. That one I need to find the M, right?
Yeah, you give me the new formula for the M, then bring the 2 pi r go in. Can or cannot?
Wait, let's try. I think that.
I wait the JS done. Done, you finish? You can give me the formula. You got 2 done here. Where is the done way? Okay. I show here. So you check. If you got do already, then you shine. You want to tell me what is that? Then I show here. Then you check. Okay, first round is a M equal the V squared R then over G. I told you to bring the 2 pi R over T go in. Then should be M 2 pi R over T overall go to square. Then it's R over the G. Okay, now which part we can cut? I want to make it become shorter. So 4 pi R square all go in. 4 pi square. Then the R square, another R become cube already. Then we still got 1 T become square over the G. So which one should be come down? The T square can come down lah. So now your M formula is 4 pi squared R cubed over G. So this one is another formula to find either mass of the sun, either the mass of the earth. So we got 2 formula we can find about the mass. Either one, this one, another one should be this one. Okay. So we just until here only. Centripetal force. First round we learn FC. Yeah, FC the formula is M V squared over the R. Then the A is V squared over R. Then after that, no more idea. Straightforward come to this part. Okay, this one is the first and second we learn. Then we learn this part. Okay, the mass of the sun and also the earth, how to find it. Then after that, we know V is a 2 pi R over the T. Then I bring in. Finally, we get this one. So today, important 1, 2, 3, and 4. We just got 4 formulas you need to know. So you get it or not? You got check or not? Is it the formula same? You see? I tell you already. When I just Google me, every time I'm talking with the A. Okay, no problem, is it? Answer, please.
Yes.
Yes, who is this? What's your name? Hey, what's your name? I cannot see it. I never turn my slide. I cannot see one. This is not who talking? Okay, yes. Where are you? Okay, yes. Mr. Chok, are you here? Oh,
Yes,
Mr.
teacher.
Sorry, there's a miss. Okay, so that means I can start example 3. Okay or not?
Teacher.
Yes, done.
Teacher.
Yes.
I want to ask where is the T square going?
D square, wait
T
which
square.
one? This one?
No, first one
Yeah. Good question. You see, my T never bring out. T is here. So this one's a final formula. See, just now I eat the T already. Yeah. So 4 equation. So we try example 3 now. So let's see the example 3. We see what info they want to tell we all. Okay, example 3. Okay, this one answer. I'll show you. Okay, we go to open the example 3 question. This one. Okay, open the new one. Okay, example 3. Come, we do together. Then 4 and 5 you do yourself. Okay, period of the revolution of the moon around the earth. Okay, they give you period. Understood lah? If you period cannot using the first formula, must using the second one. The radius, orbit, there's a R. Okay. Calculate the mass of the earth. Mass of the earth. So we cannot using this formula because they got V. Unless you take out the V, you count yourself lah. So we straightforward apply just now the formula 4 pi square R cube over T squared G. Okay, press your calculator. I want to know final answer in kg.
The
Yes.
pi is fraction or decimal.
Which one? Which one?
The formula 4 pi square R3. The pi we can use the fraction, right?
The which one? The pi. Okay.
The pi.
Pi very easy only. You just press. Can you see your calculator at the bottom got one EXP? Your calculator. Can you see 0 dot got EXP? Hello.
No lah. No
Your
lah.
calculator. Your calculator different with mine. You not
No.
570. Yes or no?
I using 570 one.
Yeah lah. Can you see 0?
0.
741. Then the down one. The lowest one.
Yeah.
0 dot then EXP. Yes or no?
Yeah.
Okay. Okay. Example how you press. You press 4 first. Then you go to shift. Shift. Then after that you press EXP. Can you see the pi come out?
Yes. Okay.
Then you go to square. Okay. Then you equal first. Then you baru go to multiply your radius cube.
Okay.
Okay. So I give you 2 minutes. You go and finish. Finish. Just on the mic. I want the answer.
Okay.
For the student, you ask 4.07.
Times 10 power of 7.
5.26.
5.26. Then times power of
24.
not 26. You try again. Oh, the others is okay already, not 5.24.
5.97.
Yes, 5.97 times 10 power of
24.
yes, correct. That's the answer. Then I show you the calculation. Example 3. Okay, this one. The others you cannot get, you can see here. I think the problem is you press calculator only. And better you do the 6.67, the one, the G. That day I told already how to press. You don't need to press too long. You just constant C, no constant, CONST. Then you press 39. They will come out already the G. You press all above, then you just divide one by one. You divide the 6.67 first, you divide the G, then you equal. Then you divide again, 2.36 times 10 power of 6 square. Then you can get the answer. One step by one step. Okay, get it or not? JS Tan, okay or not?
Okay, okay.
Okay, so next one, you get it?
I get it, I get it. Get it, Rich, I get it.
Okay, so for somebody that are slow, never mind, I got record already. Later, I will share in the Google Classroom for this one video, then you can see, you can pause. Okay, so if you finish the example 3, now we need to go example 4 lah. Okay, we see the example 4, what they want. Example 4. I cannot work. Okay, example 4 is here. Example 4. Okay, let's see the example 4. The Earth that revolves the Sun with the period of 1 year. 1 year is a time. So before we do the question, you have me to settle this one. 1 year actually is how many seconds? Because we're using is a second. Okay, 1 hour. How many seconds? 1 hour, how many seconds?
3600.
Okay, 3600. So 1 day we got 24 hours, is it? So you take 3600, go to multiply 24, that one just 1 day. Okay, 1 year we got 365. Okay, then we take this one, multiply 24, then you multiply 365. Okay, that one is on second. So you convert your time first. Okay, after you convert the time, okay, your time is how many? After convert?
3.15 times 10 power of 7.
15 times 10 power of 7. Okay, this one is your period. Okay, now the question also give you the radius. Calculate the mass of the sun. Okay, again, mass of the sun. Okay, the question never give you the velocity. So we need to using 2 pi r lah. So apply a 4 pi squared r cubed. Then t squared g. Okay, again the same thing. Find what is the mass of the sun. Yeah, give you some time because the number too large already. Jaya, you finished?
Heaven.
Meiling, you okay?
Okay.
Please, you're not okay, please ask, because you don't just wait like this. If you just shy, you want to ask, then you can PM me. And PM me which part you are, don't know. Or you just screenshot
Sure.
the video. Yes. That answer?
2.01 times 10 power of 30.
Yes, there's a 2.01 and 10 power of 30. So I'll show you the calculation. Okay, so this one is a calculation. And see it? Okay, we apply the same thing. Although it's the sun and also the earth, we're still using the same formula. Okay, just you want to change the radius is for who? Okay, and also need to know 1 year. 1 year is how to convert to the second. So this one is the answer. Okay, you complete number 4, you can go through your number 5. So this one already is record. You also can record back later. So I just minimize and you see the example 5. Okay, can I go through example 5? Make sure you finish. Esther, finish?
Which one, teacher?
Yes.
Next one only. Ready or not? Okay, then we go to number 5 lah. Okay, now we go to number 5. We're going to see what's the important thing they will give you. Okay, first one, the satellite mass. Okay, they give you the mass really. Okay, the orbit of the planet. Okay, at a distance 2.74 10 power of 7. Okay, now from the center of the planet, So that means just like this one is a planet. Okay, now you got one of the satellite, their orbit. Okay, this one satellite, the mass is a 2460. Okay, then the radius, the root center to the planet, that's 2.74 times 10 power of 7. They give you radius already. Not just radius, there's a radius plus together distance. What they say from the center. Okay, now the uniform linear speed. Okay, now the question, they give you the speed. Okay, now the first one, they ask you what is centripetal acceleration. You want to find A. A formula is a B squared over R. So we just apply lah. B squared is how many? B squared is 7800. Remember, go to square. Then over the straightforward, the distance is a 2.74 times 10 power of 7. So answer for acceleration is how many?
2.22
Unit?
ms negative 2.
Yes. So this one's the answer. 2.22 times ms negative 2. Okay, then we apply the following. There's a B. Okay, B is a force, Fc. Okay, Fc actually is a m B squared over R. Okay, actually it's here, is it? Okay, we just straightforward take the mass to mass. The mass is a 2460. Okay, we straightforward multiply what we find just now. 2.22. So our answer is
5.46 times 10 negative power of 3.
Negative? Oh, negative ah?
Power, no, power of 3.
Power of 3. So the unit is Newton. Okay. So this one just a simple question. So I need to complete all the example before you leave here. Okay, can I go to example 6? Respond please. Leonard, can I go example 6?
Yes.
Well, yes. You gonna do or not? Okay, we see the example 6. Example 6, they show the two bodies, mass of m and also the small m. Okay, both body also got forces. There's a centripetal force. They pull to each other. There's a 7, not the centripetal force, sorry. Centripetal force is moving to the velocity one. This one is the Newton force, pull to each other. There's a 720 Newton. Okay, so this one we call gravitational force lah, the two bodies. Okay, based on the Newton universal law of gravitation, complete the following sentence. The greater the mass both body, then the force gravitational attraction how? Okay, answer? Greater mass. What do you think about the force?
Greater.
Big or small?
Greater.
Greater. This one just like first I call you to calculate all the Jupiter, all the Mars. What's the mass? When you find the mass of the planet is bigger, that means the gravitational force is bigger. Okay, the gravitational force attraction, how? As the distance between the bodies increases. And then further and further, what do you think about the force?
More.
More, further or? Distance between the two bodies or not radius or?
More.
Distance between two bodies. This m.
Less.
I never asked about radius.
Less.
If your radius bigger, yes, gravitational force should be higher. But now they ask about distance between two bodies, so your answer become less. Okay, then we continue with the B. What is the force of gravitational attraction if one of the mass is double and the distance between them is unchanged? Okay, Ori. Ori, the force is how many? 720. Okay, now they tell you the situation is I make the mass become double. Either one either one of the mass become double. The distance same. What you think about the force? So, calculation please. Who's on the mic already crashing? Okay, I'll show you the first part. Normal gravitational force. The formula is a G, capital M, small m, over R squared. This one is a general. Okay, now F prime. F prime means this situation. You say either one of the mass become double. So become G, 2m, and m. Got double already. So times 2 lah. Then the R squared become the same. So now F prime actually is what? Actually is 2 I take out. That's a F. Agree? Agree or not? And this one F actually is what? This one F actually, this one. So finally you tell me, now the F prime, what is the new force? 2 multiply. Hello, 2 multiply how many? See the diagram? See the diagram when two body pulling. What is the Newton?
720.
So I need to times 2 when your mass increasing. So I find it. The final answer is a 1440 Newton. So I prove already. When the mass either one, the mass should increase, my gravitational attraction should increase. Okay, then we follow by B. What is the force if the mass is half and the distance between them triple? Triple already. Now I write the formula again. F prime. Okay, then now you are half. So I make half G M small m over cube. Triple, sorry, not cube. Triple means times 3. Okay, I still square. 3r squared. But you are triple. Okay, so from here, I want to take out my normal gravitational force. So F prime, I take out all the things first. 1 over 2, I take out. Over, this one cube put in. 3 cube is a 9. 3 square is a 9. Then bracket G M and then R squared. Okay, then this one 1 over 18. And this one actually is my original F. Yeah, you can see or not? Finally, how many Newton?
40.
40. So you see, so when my mass become half and also my distance is a triple, 3 of the R, I find it my force drop already. Okay, so we go to the last. Without using calculation, okay? You don't need to count it. You just see the question, then you tell me the answer. What happened to the magnitude of the gravitational? They want to ask about the value. Attraction, if the distance between two bodies is half. Okay, means your R square become half, 1 over R square. So what you think about your force now? I do a number, you just tell me increase or decrease. Increase or decreases? No, that means we show calculation lah. If we do not, increases. Increases how many times? I know increases. I want to know. Yes, that is 4 times. Okay, how we know that increases 4 times? Then we show the calculation here. Okay, so this one is, where's my pen? Yeah, charting my pen first. Take a while, Okay, for the others, if you cannot find it, then you can try. You can try do the calculation first. Although they say cannot do, so you just show lah. You just show first. My pen cannot function. Okay. Okay, so from here we show G, capital M, small m. Okay, down should be 1 over 2 R square. Okay, so from here we also want to take out F prime equal, okay, 1 over 4. Now we become 1 over 4. G, capital M, small m, 1 over 4 R square. Okay, this one 1 over 4 I want to bring up. So F prime will become 4. Then G, M, and R square. So this one actually is a F. So your F prime is a 4. So that means now your force you bigger 4 times. If they ask about the number, then you take the 4 multiplied with 720 Newton. Okay, now we go to the last part. That's the 7. Okay, let's see the 7. We still got 15 minutes. Okay, we go to the 7. This one. 7 here, the last one. Okay, 7. Diagram below they show about the position of the Earth and also Sun and also the Moon. Okay, they give you the mass ready for everyone. Okay, first one, state the Newton law of universal gravitation. Okay, where to find the answer? What means of Newton law of universal gravitation? Okay, find the answer from the page number 2. Above the formula. Okay, the gravitational force between two bodies is directly proportional to the product of masses of both bodies and inversely proportional to the square of distance between the center of two bodies. So this one is Newton's law of universal gravitation. Okay, so I don't need to write. You can find it from your notes, page number 2. Okay, after that, B. Express the law of the universal gravitation in formula. Okay, what's the formula? Okay, I give the simple question for the Leonard. Leonard, pay. What's the formula? Leonard, go where already? Leonard, pay. I still got 30 minutes only. Faster.
Don't know, leh, teacher.
Formula for the first page. What's the formula? Newton law of universal gravitation. The first formula we learned for this topic.
G M1 M2 over R square.
T, apa T?
No T, G.
G. M1.
G M2 M1 M2 over R square.
Okay, good. So this one is the first formula what we learned. Just now you explain the definition, that means you explain this one formula only. Okay, then calculation. Calculate the gravitational force between 1 kg of coconut and also the Earth. Gravitational force mean the F. So G. Follow the Nixon. M1, M2. So you find it lah. M1 is coconut. Number 2 is the Earth. Then divide by the R square. That's the distance between the center coconut and also the Earth. So final answer.
9.72.
9.72. Unit.
ms -2.
Huh? I want to find force. Oh.
Newton.
So this one's the answer. I think I no need to show the calculation. You also know what is that. What is here already. Okay, then we continue with D. Calculate the gravitational force again, between the Earth and the Sun. Okay, again the same formula. G. Now first one, second one is the Sun, and also the distance between the Sun and also the Earth. So answer.
3.53 times 10 to the power of 22
3.53
times
times 10 power of
10 to 22
22 Newton.
Newton.
Okay, why my student just got Nixon 1% only? The other just on the cam only, is it? On the Google Meet only, then after that go to play already, is it? Okay, the last one, E. Okay, let's see the E. Gravitational force again. Oh no, gravitational provided. F got already. Okay, now what is the distance? They want to find R. So F we know, times 10, 20. Okay, now G. Okay, first mass is for the Earth, second mass for the Moon. Okay, now the problem is I do know R squared. But finally, they just want to find is what? Distance between the center. I want R only last. Okay, so you need to square it. Okay, give me an answer.
3.84. 3.84 times 10 power of 8.
Power of 8 unit should be?
Uh,
What you find now?
meter.
Yes, meter.
Meter.
Yes. Your answer correct or not? 3.84 times 10 power of 8 meter. Okay or not?
Correct.
Right,
Correct.
Okay.
Yeah.
So this
Correct,
one is 3.1 what we need to learn. Okay, you know every time the lesson I never release you one. So now please see here. I want you to snap photo or you want to copy. Copy I think no need lah because I got record. Later you can see back. Okay, I want to give you the homework. Okay, we got to open first. Okay, see the homework. Okay, the question here. Open. Okay, this one is the question. So I don't know you how to copy lah. You go and snap photo, or you just see later. You go back to see the video back. This one I want the answer. Okay, the question here. So after you copy, after you snap photo, you want me to change slide, I will check another question for you. Okay, I wait you until you tell me you are finished. You no need to do first. This one is your homework.
Sure, teacher.
Okay?
I can.
Yes.
You can share this this exercise to the Google Classroom or not?
Yeah. Later I will share a video also. Then I will snap this one as a photo. Then I also will share that. Okay,
Okay.
So I no need to show here so long lah. I just let you to see what is that. So later you just go to download. Okay, Okay, then this one is the first question. Then later we need to do another one. Just now got two questions, Then after that, this one. Okay, also like this one. Okay, they ask you need to find what is the gravitational force. Okay, this one your textbook also got, they got mentioned here. Page 95, textbook, question number 3. Okay, then the following is number 4 lah. Follow your textbook. The question number 4. Okay, and also number 5. Number 5. And the last one, number 6. Your textbook is no answer, I think so. And the last one is number 6. Okay, so 3 until 6 from your textbook. And the first one example, I will share that. Then this all I also will share lah. Then let you easy to get the question. So my lesson is until here. Then that's the finish. Okay. Everybody here, can you understand what I'm talking about today? Got me students, some left already. Now we got 19. Esther, anything you want to ask?
No.
No. Okay.